Hey everyone, welcome back to your new style math class with me. This is your second lesson and the first lesson where we're going to actually dive into some real math. Now, in light of your guys's initial assessment, little mini exam thing that I had you do last week, I've decided that I'm going to start off with a review of fractions in this lesson, so that's everything that we're going to see today has to do with fractions. You guys did decently well on that section, most of you, on the initial assessment. So we're going to talk about fractions in this class, and then in the next class we're going to talk about decimals, after which we will jump into percentages, and then we'll get into algebra after that. So we'll talk a little bit about fractions, decimals, and percentages, see how they all kind of relate to each other. We'll probably have some sort of like a mini quiz test thing on that a little ways down the road, like in a couple of weeks, and then we'll get into algebra. So let's jump into it. So first things first, I want to talk about the plan for today's class. So it's hopefully nothing brand new. It's hopefully stuff that you guys have all seen before. So we're going to start off with a brief discussion on when we use fractions, like what they're useful for. Then we're going to talk about, I've called it the anatomy of a fraction, basically what a fraction looks like, what the different parts are called. We're going to talk about the different types of fractions, so that's proper fractions, improper fractions, and mixed numbers, or mixed fractions, depending on what you like to call them. So hopefully that's all very, very basic review. I'm going to kind of take my time going through it for a couple of minutes, but it's nothing that should cause you too much trouble. After that, we'll get into working with fractions. So we'll do addition, subtraction, multiplication, and division of fractions, and then a couple of word problems towards the end of class. So we'll start with a brief discussion on what we use fractions for. So as you can see on the slide, this isn't anything you need to write down. If you want to jot a couple of points that maybe is something new that you didn't know already, you can. But you don't really need to write anything down from here. Basically, you should just know that fractions are one of the tools that we can use in math when we want to talk about something that's broken into a lot of pieces, something that we can't use to describe, something that we can't use whole numbers to describe. So you'll see that combines a couple of the points on the slide there. So primarily, if you want to talk about something that you can't describe as a whole number, that you have 3 of these or 4 of these, but you've got 3 and a little bit, then you can either use a fraction, a decimal, or a percentage to talk about, that little leftover piece. And so that's why we're going to talk about fractions, then decimals, then percentages. We're talking about how to deal with quantities that are in between whole numbers. So it's not 0, it's not 1, but it's somewhere in between, or it's not 4 and it's not 5. It's 4 and a little bit. So one of the really common examples that I'm sure you guys have seen when there's a discussion to be had on fractions is the pizza. And the reason that thinking about a pizza and like cutting it into a different number of slices, the reason that's useful when we're talking about fractions is it really emphasizes the point. It really highlights the point that all the pieces of the whole are the same size as one another. Now, I'm sure you guys have seen pizzas in the real world. There's usually a biggest slice and a smallest slice because they don't cut it perfectly with all the cuts going right through the center of the pizza, but it's good enough. And if you were really careful with the way you cut a pizza, then you would get all the slices to be pretty much the same size. So that's the important thing with fractions that makes it kind of different from decimals and percentages, is that we're dealing with a lot of pieces, sometimes not a lot, sometimes a few pieces that make up the whole, but each of those pieces is the same size as every other piece. So we're going to see that a little bit later on when we start doing addition, subtraction, multiplication, and division. We're going to basically just be cutting up pizzas in a bunch of different shapes. If you guys get hungry, I hope you can hold out until lunchtime to have some pizza. But yeah, so now we're going to get into talking about what a fraction kind of looks like and what the 2 main pieces are called. So this is that slide I mentioned a little bit, a couple slides back. This is anatomy of a fraction. So there's 2 basic concepts that you need to understand, and you need to understand them really well in order to be able to work with fractions. So hopefully I don't need to spend too much time on these next few slides, but here we go. So a fraction, when you see it written out like the one on the left there, 4 over 7, you've got one number on top and one number on the bottom. Now you can read it out a couple of different ways. I just said 4 over 7, but you could also say 4/7. And so basically what do these two numbers mean? Let's start with the one at the bottom. That's the denominator. Hopefully you guys have all seen that before. So that's the number of pieces that you need to make up one whole. So for instance, if you had a pizza and you cut it into 7 slices, that's what the denominator is telling you. It's telling you that if you had 7 slices of pizza, you can make one whole circular pizza out of them. The number on top is talking about how many pieces you have, or like how many pieces you're interested in at this particular time. So for instance, with that fraction 4 over 7 or 4/7, basically that's telling you that the pizza has been cut into 7ths, so 7 different pieces that are all the same size as one another, and you're talking about 4 of them. Maybe 4 of them are a certain topping that's different from the rest of them. Maybe you only have 4 slices because the rest of it's been eaten, or you're gonna eat 4 slices. So for one reason or another, you're interested in only 4 of the slices, so that's what the numerator is talking about, and the denominator is telling you how many slices you need to make a whole. Now, more generally, and for those of you that have seen algebra to any extent, you can also maybe appreciate the fraction on the right, where instead of putting numbers, I've just put letters, A and B. For those of you that haven't seen algebra or are still kind of scared by seeing letters in math, don't worry, the A and B, basically it's just telling you that it doesn't matter what those two numbers are. It doesn't have to be 4/7, it could be 7/4, it could be 2/3, it could be 112 95ths. Like, they can be whatever numbers you want, but if you've got one number on top, one number on the bottom, and a line in between them, you're talking about a fraction. The number on top is always called the numerator, the number on the bottom is always called the denominator. That's all that's saying. So now we're going to get into talking about proper fractions. So a proper fraction is one in which the numerator, the top number of your fraction, is smaller than the denominator. So basically, if you look at the example on the screen with the pizza, let me get my little laser pointer here. So here you've got a pizza, but you've only got 3 of the slices. Now if we go around and we count how many slices of pizza there should be, if we start right here where the pointer is, then, so that's number 1, 2, 3, 4, 5, 6, 7, 8. So we've got 3 slices and then we're missing 5 slices. But if you count all the way around, you'll see that this pizza originally had 8 slices. So the denominator in our fraction down here is 8 because you need 8 slices to make a whole pizza. But we only have 3 slices, and that's what the numerator represents. So this fraction could be, if you're asking the question, how much pizza do we have left? You'd say 3/8 of a pizza, 3 slices of a pizza, where each slice is 1/8 of the whole thing. So that's what that says over here. The numerator is 3 because we have 3 slices. The denominator is 8 because we need 8 slices to make a whole pizza. So if we had 8 slices, we'd have a whole pizza. But because we only have 3, we're talking about 3 in the numerator, but we still keep that 8 in the denominator because it tells us some more information about the size of each slice. So in terms of the name proper fraction, the way I think about it is when you start working with fractions, it's because you want to talk about something that's between 0 and 1 of something. So like you either have, so you don't have the whole thing, you don't have none of it, but you have part of it. And you'll see this a lot in your daily life, that when you kind of talk about fractions, maybe without realizing, you're saying things like a half, a quarter, a third, 2/3, 3/4, all these numbers that are between 0 and 1. You know, it's like half an hour. That's not 0 hours. That's not 1 hour. It's between 0 and 1. So proper fractions are talking about things that are also between 0 and 1. So you're talking about something that you don't have enough pieces to make a whole in that fraction that you're talking about. So like in this example with the 3/8, we don't have enough slices of pizza to make a whole pizza, or to have like a whole pizza and then some slices left over. We don't have that many slices. We've only got 3 of them. We don't know where the other 5 went. But so that's proper fractions, where the numerator is smaller than the denominator. Then we've got improper fractions and mixed numbers. So after you get used to working with proper fractions, improper fractions look kind of strange because these are ones where the numerator, the number on top, is bigger than the denominator, the number on the bottom. And that can be a little bit strange when you're getting used to it because normally, like I said on the last slide, we use fractions to talk about things that are between 0 and 1. You know, you'll say things like half an hour, right? So like you're talking between 0 and 1. Suddenly with improper fractions and mixed numbers, now you're talking about things that are bigger than 1. So we're going to look into a couple of examples using the pizzas again, but the difference between an improper fraction and a mixed number is the improper fraction is really paying attention to how many of the little pieces you have, while mixed numbers care more about how many whole things can you make before you have just a few spare leftover pieces. So for instance, if you're talking in terms of time, if you were to say something like 1.5 hours, that's something more like a mixed number because you've made as many wholes as you could. You made a whole hour and then you had a half hour left over. So let's say 1.5 hours or an hour and a half. That's like a mixed number that you're talking about. Maybe if you were talking about that in terms of an improper fraction, maybe you say something like 90 minutes because you know there's 60 minutes in an hour, but you're interested in counting the minutes. So even if it's more than an hour, you're just going to say that. So that's kind of the distinction there. That's not a great example, so we're going to jump over into looking at the pizzas. So here we've got 2 pizzas. Both of them have been cut into 8 slices, even though the 2 pizzas look a little bit different from one another. So we can count that just to be sure. This is number 1, 2, 3, 4, 5, 6, 7, 8 for the first pizza, and 1, 2, 3, 4, 5, 6, 7, 8 for the second pizza. So we do have 2 pizzas that were originally cut into 8 slices. Now, if we want to write this out as an improper fraction, we want to count how many individual slices of pizza we have left. So we've got this whole pizza, which we know is made out of 8 slices. So we know that's 8 slices right there. You can count them again if you need to. And then over here, we have 3 slices, one over there, one here, and one on the left. So altogether, that's 8 slices over there and 3 over here. So that's 11 slices of pizza, where each slice is 1/8 of the entire pizza, right? For each slice is 1/8 of the whole thing. So if you had 8 slices, you could make a whole pizza here, and you have 8 slices to make a whole pizza over there. So because you need 8 slices to make a whole, that's the denominator in our improper fraction over here. And our numerator is how many slices we have in total across these 2 pizzas, which is 11 slices, 8 in the first pizza and 3 in the second. So that's 11/8 of a pizza, which is what we have. As a mixed number, this is answering the same question with a little bit more emphasis on how many whole pizzas you could make. The first question is more paying attention to how many slices you have. The second question for answering this as a mixed number, you're trying to make as many whole pizzas as you can, and then you write the leftover bit as a proper fraction. So here we can see we've got 1 full pizza. Even though it's been cut into 8 slices, we still have all 8 of those slices. So that's still a full pizza over here. And then we've got 3 slices left over. So we say we've got 1 whole pizza and then 3/8 of a leftover pizza. So that's the 2 ways that you can describe the amount of pizza that we have here. So with that, hopefully we're ready now to jump into fraction addition and subtraction. So in order to add and subtract fractions, it's a little bit tricky if you've forgotten this or you're new to fractions and you haven't done this before, but so if you're talking about like adding 2 fractions together, let's say, we need the denominators of those 2 fractions to be the same. And that's called a common denominator, so that's what I've put here. Now, if you're not used to this concept, or if you haven't seen anything like this before, you should absolutely write this down. This is the name we give to this special thing that we have to make sure we have for fraction addition and subtraction, a common denominator. So the denominator needs to be the same in both the fractions that you're trying to add or subtract. Or if you've got a whole bunch of fractions, the denominator needs to be the same for all of those fractions. So we call it a common denominator. Now, once you get really used to fractions, maybe you kind of stop needing common denominators. But the the basic idea is that the common denominator makes it really easy to talk about the result you get after you've done your addition or your subtraction or whatever, because all the pieces are the same size as each other. So they're like, you know, you can kind of mix and match, and your result will always look the same because all the different pieces you have are all the same size as one another. So it doesn't matter exactly which one you put where, or you know, anything like that. But if the pieces are different sizes, now it gets a little bit tricky to know exactly how much you have. So if you look at the two pizzas here, one of them is the same one that we've seen twice already. It's cut into 8 slices and we've got 3 of them. But the other one's only cut into 4 slices and we have 3 of them. So now if you were to, like if I were to ask you how much pizza do we have, well, we've got 3/4 of one and 3/8 of another, that's a little bit harder to figure out just like that. If this was 3/8 and that was 3/8, then that means all the slices are the same size. Just count up the slices and you pretty much have your answer. Just a little bit of like simplifying to do. But now it's a little bit tricky because we've got 3 slices here, 3 slices here, but they're not the same size. So if it's not, you're not being fair. If somebody asks you, oh, how much pizza do we have? And you say, oh, we've got 6 slices. We have 6 slices, but these slices are way bigger than those slices. So it's not really the same thing. And if you want to know exactly how much pizza you have, then it's like, suppose you try and take 2 of these slices and you put them over there. Actually, it's not that hard in this particular example, but sometimes with fractions, it'll be a little bit complicated that you try and put these slices over there and you've got like just a little bit that's spilling over into a second pizza and you don't quite know how much. This isn't one of those examples because I picked it to be an easy example, but what we're going to do is we're going to answer properly how much pizza we have with these 2 portions of the pizza, or portions of these 2 pizzas, but we're going to do it right. We're going to do it with a common denominator. So let's jump into that. So as I said already, the first pizza is made up of 4 slices and we have 3 of them. So you can say that we have 3/4 of a pizza, right? Let me get my pen here. Is that the pen? I think that's the pen. Yeah. So we could say that this one is 3/4 of a pizza because we need 4 slices to make the whole and we have 3 of them. The second pizza, we have 3 slices, but we need 8 slices in total to make up the whole. So here, this pizza could be represented as 3/8, the amount of pizza that we have. And I don't really know why I wrote those out because I'm pretty sure that's what's coming up next. Yeah, so our addition problem here, basically, if somebody asks you how much pizza do we have here, you're basically tasked with solving this addition problem, 3/4 plus 3/8. Now the way you can get a common denominator is you don't care what's in the numerator, you just ignore that, and you're interested in these 2 denominators. You see the 4 here and you see the 8 there. And basically, if possible, you'd like to multiply the smaller one by some number that makes it exactly equal to the bigger one. So in this case, that would be 4 times 2, right? So if we've got, I'm just going to try and squeeze it in there. So we've got 4 times 2 would give us 8, right? And then the rule with fractions, I'm assuming you guys have seen this, but let me know in the comments or something if you haven't. Whatever you do to the bottom of the fraction, you also have to do to the top. So the top, the 3 that's in the numerator, we also have to multiply that by 2 so that we're not changing the question, right? So what you end up with then is basically you're cutting every slice from the first pizza in half, right? We've turned the pizza from being one that you used to be able to make up the pizza with 4 slices. Now you're doing it with 8 slices. So basically what we've done is we've done this. If you look up in the top right corner there, I'm basically cutting this pizza so that it now is also 8 slices, just like this pizza down here. So now you can count these, 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 slices up there. We've got 8 slices down here, right? And now we can just look at that and we can count out how many slices we have. We have 1, 2, 3, 4, 5, 6. So that's where we get this 6/8. So the first pizza, 3/4, that's the same thing as 6/8. Basically, we've cut every slice in half. So the 3 became a 6 because we've got twice as many slices, even though they're smaller. And then instead of having 4 slices make up the whole pizza, now it's 8 because we cut everything in half. So our addition problem becomes 6/8 from the first pizza, from this pizza up here, is now 6/8, and then plus 3/8 from the second pizza over here. So when we do that addition problem, nothing happens to the denominator. Well, once you get the common denominator, you ignore it, and then you just kind of pretend your addition problem is just dealing with the numerators. So you have 6 plus 3 is 9, and then you just carry that denominator over into your answer without changing it. So we got 6/8 plus 3/8 is 9/8. So we've got 9 slices of pizza that are all the same size now. Each slice is 1/8 of the entire thing. And then if we write that as a mixed number, that's one whole pizza and an extra 1/8 of a pizza. So like one whole pizza and then one slice left over. So that's what we have there. And that's all there is to it for this kind of question. It's exactly the same thing when it comes to subtraction, except of course, once you get to this stage, you're not doing an addition problem with the numerators, you're doing a subtraction problem. But the rest of the steps are exactly the same. You get that common denominator, and then you handle your addition or your subtraction problem with the numerators, and you carry that denominator over. And then at the end, generally, it's good practice if you're writing out your final answer and it turns out to be an improper fraction, it's good practice to then rewrite that as a mixed number. So that would be like your final answer is 1 1/8. So here is your opportunity to practice. So you can hit pause. I'm going to wait a couple of seconds to give you a chance to pause, work through these problems for the next couple of minutes, and then press play and we'll talk about the answers. All right, let's talk about the answers. So for the first question, pretty straightforward. You already have a common denominator. Both of the fractions, both of the terms here have a denominator of 7. So you don't have to do anything to that. You just have to add up the numerators. So 3/7 plus 2/7, that's going to be 5/7. That's it. That's all there is to it. For the second one, again, you don't have to change anything with the denominators. They're both the same. They're both 5. So you just add up the numerators. 1/5 plus 4/5. 1 plus 4 is 5. So that's 5/5. But that's like you had a pizza that's cut into 5 slices and you have 5 slices. So why would you say you have 5/5 of a pizza when you could just say I have one pizza, right? Because you need 5 slices to make the whole and you have 5 slices. So you have one whole pizza. So if you got 5/5, you can rewrite that as 1. That's technically like a mixed number in that you've tried to make as many wholes as you can, but then of course you didn't have a fraction left over. So it's not a mixed number, it's just your answer just happens to be a whole number. Then here it gets a little bit tricky with the subtraction problems because I've changed up the denominators. So you have to do an extra step to make the denominators the same. So with this first of the two subtraction problems, we can see that one of the denominators is twice as big as the other. 8 is twice as big as 4. So if we look at the second fraction, this 1/4, and we multiply the numerator and the denominator both by 2, then instead of having 1/4, we'll have 2/8, right? Because 1 times 2 is 2 and 4 times 2 is 8. Now we've got the same denominator, 8 in both cases. We just do the subtraction problem. 3 minus 2 equals 1. So you're left with 1/8 as your answer there. And then for this last one, there's a couple of different ways to do it. I've given one of those ways here. So one of the ways is you could look at this second term and you say, 7 times 2 is 14. So let me multiply the 7 by 2, let me multiply the 2 by 2, and let me do it that way. The other way you can do it is to simplify the fraction down a little bit. You notice that both of these are even numbers. And this simplifying of fractions isn't something I talked about because this is supposed to be a review, so it's supposed to be stuff you've all seen before. But you should be able to look at certain fractions and you can just by looking at them, you can tell that I can make this fraction easier to work with by making the numbers smaller. So you see that 12/14, 12 can be evenly divided by 2, right? 12 divided by 2 is 6, and 14 divided by 2 is 7. So again, whatever you do to the top, you do to the bottom. 12 divided by 2 gives you 6, 14 divided by 2 gives you 7, and all of a sudden we've got a common denominator here. So we've got 6/7 minus 2/7 because we've left the second fraction alone, and we get a final answer of 4/7. So hopefully that all made sense for addition and subtraction of fractions. If not, let me know in the comments, shoot me a WhatsApp message, Instagram message, whatever you need. Now for fraction multiplication and division, it's actually even easier than addition and subtraction. If you're multiplying two fractions together, all you need to do is multiply the two numerators together and the two denominators together. So you can see in this example, if you've got 2/5 as your first fraction and 1/2 as your second fraction, you can just go ahead and just multiply right across. So this, in this problem, I'll just grab my pen. So this here would be, you're just multiplying this 2 by that 1 and this 5 by that 2. So you get 2 times 1 is 2 and 5 times 2 is 10. And then here you can reduce. 2 and 10, they can both be divided by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. And that's how you get this answer of 1/5 right over here. Now, I'm going to let you sit and think about what this means. Like if you're multiplying an amount of like the pizza, like a number of pizza slices by a half. I'm going to let you sit and think about that, and if you would like to have a discussion about it amongst yourselves, you're more than welcome to. But right now I just want to make sure you guys at least understand the mechanism of doing the multiplication and division. So for multiplication, it's really easy. You take your two numerators, you multiply them together, you take your two denominators, you multiply them together, and that's your answer. If you need to do a little bit of simplifying, you can do it. But other than that, that's all there is to it. Now for division, it's a little bit different, but it's not that hard because when it comes to fraction division, we actually just want to turn it back into a multiplication problem. So there's 3 steps. The first step is you're going to flip over the second fraction. So you've got like the first fraction divided by the second fraction. So that second fraction is the one that we're going to flip over. The numerator is going to become the denominator, and the denominator is going to become the numerator. And then when you do that, you're also going to change the sign from a division sign to a multiplication sign. So that's effectively what you're doing, is when you're flipping over the fraction, you're also changing the sign, and the two like pretty much cancel each other out, so that you're not changing the problem. And then basically what you're left with is a multiplication problem. So you already know how to answer that from the previous slide, so then you just carry on and solve the multiplication problem. So in the example here, you've got 6/5 divided by 3/2. So your first step is you take this fraction, this 3/2, you're going to flip it over so that it becomes 2/3. And then you change the division sign to a multiplication sign. So now you can see instead of the division sign here, we've got a multiplication sign there. And instead of 3/2, we've got 2/3. Then you go through and you do your multiplication. 6 times 2 is 12. 5 times 3 is 15, and then you see that both of these numbers can be divided by 3. 12 divided by 3 is 4, 15 divided by 3 is 5, and there's your answer, 4/5, or 4/5. And with that, it's time for you guys to do a little bit of practice. So once again, I will give you a sec to hit pause, take a couple of minutes, solve these problems, and then we'll get back to the rest of the video. All right, let's take a look at the answers. So for the first one, there's a couple of ways you can do it, and I'm showing both of them this time. So we've got 3/4 times 2/3, or 3/4 times 2/3, or 3/4 times 2/3. You can read it however you like. So the first way is you can just carry out the multiplication problem. So you do 3 times 2 is 6. 4 times 3 is 12, and then you notice that 6/12, you can divide both of those numbers by 6, and you get an answer of 1/2. The other way that you can do it is that right at the beginning of the problem, you notice that you've got a 3 up here, and a 3 down here. And those, you can cancel them both out. Hopefully you guys have seen this with fraction simplification. Let me know if you haven't, and then I can make another video where we go in more detail with that. But this 3 and that 3, if we divide them both by 3, then we're left with a 1 here and a 1 here. And then same thing with this 4 and this 2, they can both be divided by 2. So if we do that, this 2 becomes a 1, and this 4 becomes a 2. And then we're left with this over here. So the two 3's canceled out, so now instead of having a 3 in the top left, we've got a 1 and a 1 in the bottom right. And then the 2 and the 4 became a 1 and a 2. And now this is 1/2 times 1, basically. So it's just going to stay as a half. Or you can, again, do the multiplication going across. That's 1 times 1 is 1, and 2 times 1 is 2. Either way, you're going to get an answer of a half. So for the second problem, now it's a division question. So what you can do here, the way you're always going to start with your division question is you're going to flip over the second fraction and change the sign from division to multiplication. So instead of having 1/5, this becomes 5/1. We have a multiplication sign. Now here I opted to cancel out the two 5's right at this step. So you can see they both become 1's over here. And then that's 3 times 1 is 3, 1 times 1 is 1. Anything over 1, that's a whole number. So our final answer for that one is 3. And then for this one, we can do a little bit of simplifying here as well by noticing that 12 and 8 are both divisible by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So that's what we've got in this first step, is we turn 12 over 8 into 3 over 2. And then we multiply that by 3 over 4. So 3 times 3 is 9, 2 times 4 is 8, so we have 9/8, and then we rewrite that as a mixed number. And this last question here, 1/14 divided by 2/7. This is one where I'm emphasizing the importance of canceling things out kind of when you can, because otherwise you have to deal with this pesky huge 14 over here, which can be a little bit scary because 14 is not a number that you work with as often as like single digit numbers or maybe 11 or 12. Then it starts getting into a little bit of dicey territory after that. So our first step, we flip over the 2/7 so that it becomes 7/2. We change the division sign to multiplication. And then here we notice that we can cancel out this 7 and this 14. The 7 becomes a 1 and the 14 becomes a 2 when we divide both of those by 7. So we're left with 1/2 times 1/2. And then you just go across, that's 1 times 1 is 1, and 2 times 2 is 4. And you're left with a final answer of 1/4. So hopefully that all makes sense. Let me know through some medium if it doesn't. Now we're going to jump into a couple of word problems. So just looking at the time, I know this video is already 33 minutes in. So I'm going to let you guys look at this question for sure. I'm going to talk briefly going into the solution. But if you are running out of time for class, then try to do this question for homework, and then we will dive into the answer whenever you guys are free. But I'm going to give you a sec to hit pause and try and work through it, and then we're going to talk about the answer. All right, so now let's take a look at the answer to this word problem. So we've got a standard deck of cards has 52 cards. Each of the 4 suits has a set of 3 face cards. That's the king, the queen, and the jack. Some people also include the ace, but that's why I've specified for this question. It's only the king, the queen, and the jack for each suit. What fraction of the whole deck do the face cards make up? So the first step is we have to figure out how many face cards there are in the entire deck. So we know that each suit has 3 face cards, and there's 4 suits in a deck of cards, right? Spades, diamonds, clubs, and hearts. So altogether, that's 3 face cards times 4 suits. That's 12 face cards in the entire deck. So then we have that the fraction of the entire deck that's made up of face cards is 12. That's 12 face cards divided by 52, the number of cards in the entire deck. So our whole fraction for the answer of the number of face cards in the entire deck, the fraction of face cards in the entire deck is 12/52. but both of those numbers, and this is maybe a little bit tricky to see, but both of those numbers can be divided by 4. And if you do that, you get an answer of 3 over 13, which also makes sense if you think about it that each suit has 3 face cards, and there's 13 cards in each suit. So since every suit is identical, the overall fraction isn't going to change. You're going to have 3 face cards for every 13 cards that you have in the deck, and that's your fraction. So hopefully that problem made sense. I'm going to give you a second problem. This one's a little bit trickier, so take your time, pause, and work through this one, and then I'm going to talk about the answer, and that'll be it for today. So the question is, at the 2022 FIFA World Cup in Qatar, there were 6 teams from countries in Asia, 5 from countries in Africa, 4 from North America, 4 from South America, and 13 from Europe. So the question is, basically write out the fraction of teams that were at the tournament from Asia, from Africa, from the Americas together, and from Europe. So that's your task, is you got to write, for instance, for our first step, for Asia, you got to write the number of teams, or you got to write the fraction of teams at the World Cup that were Asian countries, countries from the continent of Asia. And you've been told that there were 6 countries from Asia. So, and then you can repeat that step for Africa, the Americas, and Europe. And now let's take a look at the answer to this problem. So in order to write any of these numbers as a fraction, any of these quantities for like the number of teams from any of these continents, we first need to know how many teams there are at the tournament, because that's going to be the denominator, right? We need to know how many teams does it take to make up one whole World Cup. And the easiest way to do that is, this question is a little bit tricky because I didn't tell you to do this, but basically you just have to add up all the different teams. This is all the teams that were at the tournament: 6 from Asia, 5 from Africa, 4 from North America, 4 from South America, 13 from Europe. So if you add all of those together, you get that there were 32 teams. A lot of you wrote after the introductory lesson that you're into football, so hopefully a lot of you already knew that, but for those of you that didn't, you just have to add up those numbers and you get 32 teams. This is going to be the denominator because it's the total number of pieces of the whole in this case, where the pieces here are the teams. Now let's start with looking at Asia. So the fraction of teams at the World Cup that were from Asia is just the number of teams that we know came from Asia over a denominator of 32, because that's all the teams at the tournament. So that's simply 6 over 32, which if you divide both of those by 2, you get 3/16. So that's the answer for Asia. Now let's look at the rest of them. In the case of Africa, we had 5 teams from Africa at the World Cup, so we can write that as 5 over 32, but that can't be reduced down any further because you can't divide both of those by a common factor. So that's the answer for Africa. Now for the Americas, the reason I worded it this way is I wanted you to remember or realize that there's an extra step that you have to add together the number of teams from North America and South America and write that whole thing as a fraction. So for North America, there were 4 teams, so that's 4 over 32, 4 out of the 32 teams at the tournament. And for South America, that's 4 out of the 32 teams at the tournament. So adding that all up, you get 8 over 32, which if you divide both the numerator and denominator by 8, you get an answer of a quarter, or 1 over 4. So that's the answer for that bit. And then for Europe, it's the same thing we've been doing. It's 13, that's the number of teams from Europe, out of 32 at the entire tournament, and that doesn't reduce down because you can't divide it by anything else. And if you want to be sure, so that's the end of the question, but if you want to be sure that you did it right, you can just kind of backtrack and check that you did all your steps right by adding up all those numbers that we got. So first we got 3/16 for Asia, 5/32 for Africa, 1/4 for the Americas, and 13/32 for Europe. And if you add all those together, first you have to get a common denominator for all of them. You add them all together and you should get one whole World Cup, 32 teams out of 32 teams. So that's it for today. This video is just about 40 minutes long now, but I imagine it's gotten a little bit longer as you guys work through the practice questions. Do let me know if you have any questions in the comments, on WhatsApp, on Instagram, whatever. Just find a way to get in touch with me. And if there are no questions, then I will see you all in the next video. Have a good one.